A very good morning, students. In today's topic, we are going to see about satellite communication. A satellite is a celestial body that orbits around a planet. So, Moon is the natural satellite of the Earth. So, in terms of aerospace, a satellite is a space vehicle that is launched by humans and that orbits around the Earth. It is nothing but a passive reflector that bounces signal from one place to another place. So satellite is a act as a passive reflector. It will collect the data from a center and it will increases the gain, and then it transmitted the data back to the receiver section. So why we are going for this satellite communication means it does not require a sophisticated electronic equipment on board. And what are the disadvantages we see means it requires a beacon transmitters for tracking and ranging, and it inefficient use of transmitted power. So in order to cover a very large area, while we are going for a mobile communication means we need more number of repeaters placed in a distance. Okay, the repeaters will collect and then it boosts up the signal's energy, and then it retransmitted the signal back to the receiver. So in satellite communication there is no need of more number of repeaters. So in order to minimize the number of repeaters, we are going for satellite communication. It covers a very large area. And the satellite communication works according to the Kepler's law. Kepler's proposed three laws, and these three laws tells in detail about the planetary motion of the of an object in a space. Okay, so in the Kepler's law, first law, a satellite will orbit a primary body following an elliptical path. Any satellite that revolve around a primary body, that is a planet, then it chooses an elliptical path to revolve around the planet. So what is the second law defined? In the second law, if it takes an elliptical path to revolve around a planet, at some point the satellite comes closer to the planet, and at some point the satellite goes far away from the planet. So those 2 points, they call it as apogee and perigee point. Okay, so the point where the satellite and the planet are comes close to each other, we call it as a perigee point, and there the velocity increases, and when the planet and the satellite are far away from each other, then it is called as an apogee point where the velocity decreases. So the third law tells in detail about the distance calculation between a primary object and the satellite, that is our Earth and the satellite. So the satellites can be classified into various types, depends upon the applications. Depend upon the distance it placed above the Earth, we classified the satellites into three types: low Earth orbit, medium Earth orbit, and geosynchronous orbit. So in each orbit, the distance between the Earth and the orbit differs. So for a medium Earth orbit, it takes 6,000 miles to 12,000 miles above the Earth. And in geosynchronous Earth orbit, it takes 23,000 miles above the Earth's surface. Other than this type, we also classified the communication satellites depend upon the path they are chosen. We classified into an inclined type, equatorial type, and a polar type. The inclined orbit is this orbit. So to cover the specified area, we are using this inclined orbit, and the equatorial orbit comes nearer to the equator of the Earth, and the polar orbit is used to cover the polar region of the Earth. So in the next class, we will saw in detail about the architecture and the block diagram of a sender, receiver, and the transponder of the satellite communication unit part. Thank you. Thank you, students.